Everybody knows well that a road network is a valuable capital asset, and therefore it is extremely important to effectively and efficiently preserve it. In order to carry out effective road management, it is essential to know how to preserve it. Therefore, the first step will consist of doing an inventory of the assets of the network. Thus, the location and classification of the elements will be known. These tasks are done with high-performance equipment travelling at the speed of the road. It is a fact that road surfaces constitute 80% of the investment to be made in the maintenance of highway authorities. Given their extent, it is necessary to find out about and control their composition and condition, aspects that are related to structural and functional parameters. The functional characteristics are linked to the road surface wearing course. There are two essential factors. One is roughness, which indicates the degree of comfort perceived by the user when driving on the road. This factor is discovered by measuring the longitudinal profile. If the profile is not uniform, vertical accelerations will be produced in the vehicle, in addition to greater vehicle operating costs and an increase in trajectory times. Another of the functional characteristics is the adherence between tyre and road surface, or friction. Any aggregate which stands out from the bitumen gives a certain level of friction which impedes sliding. The passing of vehicles erodes these aggregates and leads to polished surfaces, possibly leading to vehicles going off the road on curves or colliding on straights. This characteristic is measured using equipment which stimulates the worst friction conditions possible by pouring water on the road surface. In addition, there are structural characteristics. The supporting capacity of the road surface is analysed by measuring the vertical deflections or deformations produced due to the passage of heavy traffic using simulation equipment. The deflections make it possible to find out the degree of fatigue in the material. The state of the layers must guarantee passage to the traffic load throughout its useful lifetime. So as to be able to undertake proper management, it is crucially important to group all of this information together in a database which will serve as the feed for a management tool. The quality of the collected information and an assurance of the location to which it corresponds make up the basis of reliable results. In addition, so as to be able to predict what is going to happen in the future, it is necessary that the data is collected periodically. If this is not done, then it is not possible to calibrate the evolution models necessary to undertake effective preventative management. It is clear that the maintenance of some elements can only be carried out correctively, as it is difficult to foresee their evolution. But in other cases, it is possible to apply preventive policies which allow the manager to anticipate problems. Regrettably, in a lot of cases, the corrective maintenance of road networks is still being carried out, which entails numerous disadvantages. Action is taken when the defect is already evident, that is to say, the road dictates when and where to act. In these cases, until the repair is carried out, the users drive on a road in poor condition and as a consequence suffer the corresponding danger, wear to vehicles and loss of time. In addition, the cost of corrective action put off to the last minute can be 5 times greater than the cost of preventive action. And what is most important, the road, as a capital asset, quickly loses value and impacts on the country's economy. To carry out preventive management, it is necessary to have a system which is capable of storing and exploiting a wide range of aspects. The ICARO application developed by the Roughness group covers planning of periodical measurements or checks of the elements, anticipating preservation action, planning and optimizing investment using the resources available, recording, documenting and evaluating routine work, checking and analysing the degree of compliance with the standards set, speeding up decision-making. In short, ICARO makes it possible for the authority or the concession to increase the service level offered to users and reduce their costs. It is well known that one of the indicators of the level of development in a region is, without doubt, the state of its road and byway network in urban areas. Developed countries apply this management model from the outset. In turn, developing regions incorporate this model when their economic capacity allows them to take care of non-basic aspects. Management systems are designed to save by applying preventive policies, but this type of policy can only be put into practice once a certain level of quality has been reached. Before reaching this level, the systems can only help in prioritizing action. The real preventive management will begin later. The aim of the management models is to reach a degree of commitment towards the citizen, guaranteeing that resources will be optimized in order to provide the best possible maintenance. To do that, it is necessary to understand the investment possibilities for maintenance, to determine the degree of quality that can be achieved with the said investment, and to define adequate performance standards, establishing those thresholds which will determine compliance. Everything must be directed towards achieving a balance between the objective to be reached and the investment to be made. The Roughness Group has a simple but powerful management system known as ICARO, developed over 10 years ago and implemented in many organizations, both private and public. Roughness also has a fast, effective team of technicians specializing in maintenance management who understand the techniques, their foundations, and the way they must be applied. The ICARO system will provide managers with the technical support to justify when, where, and how much must be invested in maintenance, and the citizens will testify to the improvements in infrastructure. That is why it is engineering, the set of scientific techniques and knowledge applied to the research, completion, and utilization of new technologies for resolving problems that directly affect people.